All right, thank you. So if we start then. So Mika Hatanpää is my name, and I'm coming from Nokia side, and they're working with the Nokia airframe data center solution and running the R&D for that function. And the topic for today, what I will be talking about is some experiences that we have had about the let's say deployments of the OCP gear, especially the OCP Open Rack gear with the telecom vendors and with the telcos and within Nokia as well. So briefly, the agenda that I will be talking about is here. So I will talk a couple of words about the telco transformation and go into the network functions virtualization architecture and the typical telco deployments that we see there, how the networks are being built. Then I'll talk about the Nokia Open Rack solution briefly, just to describe what we are deploying actually, and then what are the benefits briefly. But then I think the main topic for today's discussion is this experiences part, then about the Open Rack version 2 deployments. So first of all, about this telco transformation and the typical NFV to NFV and the typical telco deployment architectures. Some drivers why we are doing this and how we see the world changing is that the service providers need to be able to adapt much faster than they have done in the past to the demands of the digitalized business. What that means in practice in here is that I'm talking about let's say moving from people and devices to the people, devices and things that are connected to the network, and at the same time the capacities and the amount of traffic in the network is really increasing tenfold, hundredfold, thousandfold. And this is happening as we speak with the LTE networks already and is expected to accelerate when we are moving towards the 5G networks and 5G architectures. And really to be able to be 5G ready and to be able to fast deploy the new type of services in the networks, we do see that the networks need to be cloudified. So the cloudified architecture provides the agility and scale for increasing capacity and deploying new services fast. So how we see the networks is that there's different types of demands for performance and the agility for the network. So first of all, we need to address the fast-growing capacity demand and basically trying to build networks that incorporate the best web-scale best practices in terms of efficient scalability, robust performance, automated operations, and really the low-cost TCO for the networks. But then at the same time, especially when moving towards 5G and new type of mobile edge computing applications, there is a strong demand to drive down the latency for the services that are being deployed. And due to this, we do see it so that there are different types of data centers in the networks and how the networks are being built. So first of all, there are the centralized data centers which are more like, let's say not exactly like IT data centers, but there's a lot of similarities there. And there really we can deploy OCP gear in order to let's say have the lowest cost of lowest TCO and high performance for the services that we are deploying there. But at the same time, especially when we're moving towards the edge of the network, there are distributed data centers and which need to then provide the low latency for the services that are being deployed there. So really the difference compared to web scales typically is that they just a couple of very large data centers where they provide the services to, but in the telecom networks it's really so that there are data centers and cloudified where we can cloudify the services, but the overall architecture is really distributed, that there are centralized, regional and local or edge data centers there. Then some challenges that we see where we come from is really that the networks today, they run on purpose-built bare metal hardware and applications, bare metal applications. And that really means that there's a huge effort to operate and maintain all the different types of network elements and the services in the networks, because everything is more or less different. All the hardware platforms are quite different for the different applications and so on. And when we are moving towards the kind of NFV architecture, really the main target there is that we have a uniform platform for as many services as we can. And so that's the target there. But really, when we look at the requirements of all the different legacy network elements and the different legacy hardware that we have there, and trying to do the same with the kind of unified hardware platform, that is a huge challenge that we see. Okay, I already mentioned that really the architecture of the telecom networks, how the gear is being deployed is this. So we started talking about this already maybe 10 or close to 10 years ago already, that this is the direction where we are going. And I think what we see today is that really the deployments are actually happening like this, that there are a few central, not only one, but typically the networks have maybe up to 5 to 10 of these more centralized locations. But then there's a lot of functionalities that are being deployed in the regional data centers. And there are typically tens of these in the networks, even hundreds, of course, depending on the size of the network overall. But then at the same time, especially when moving towards 5G and the mobile edge computing, there is a need to also have the edge locations where we have enough computing power to run the different types of services there, providing the low latency for the services. There are also different types of demands or limitations of these different locations in terms of, for example, physical size, cooling capacities, and so. And in these centralized locations, they are more like data centers in a sense that the equipment can be quite deep. There's good cooling capacities, good power availability, and so on. But when we move towards the edge of the networks, then typically these limitations are more strict, and there's the typical telco requirements come more and more relevant there with the, let's say, physical dimensions, not more than 600 millimeters, fulfilling all the NEPS requirements, and so. All right. Then what we are actually developing, and what Nokia is doing, so we have the airframe portfolio with rack mount servers, 19-inch rack mount servers, 1U, 2U servers, switches, and so. But talking about today is OCP Open Rack gear. We have also in the expo area, so you're welcome to take a look at that if you haven't yet. But this Open Rack version 2 compatible platform that we are deploying or started deploying last year, and it's heavily increasing this year. Then what we have done is that we have done some enhancements for telecoms for the equipment, including my shielding, fulfilling the regulatory requirements, adding more different power options for the telecom use cases, having the seismic tolerance. We have tested that, fully tested that, and verified that we can fulfill Zone 4 seismic requirements, and then we have increased the power capacities. And one thing that we see also quite important is that even if when we started, we were actually thinking that, okay, this gear will be changed in the networks every 3 to 5 years. Still, the requirement seems to be so that the equipment is expected to be maintained and supported by Nokia for 7 years or even up to 10 years, which those are already quite old servers, but still, that's coming up in all the RFQs that we are seeing. So then, about the solution that we have there. So we have an Open Rack version 2 solution, which is just fulfilling the Open Rack version 2 specification with 2 power zones, up to 25 kilowatts power per rack. Then server nodes, which are these triplet nodes, similar to what Facebook has been using. There will be another presentation in the server track as actually today about this Skylake server that we are introducing there, which is a Nokia design. And then the storage nodes, their switches, and so. It's a fairly standard looking system fulfilling the OpenRAC version 2 specifications. Well, some benefits that we see overall and actually this is something that we have calculated, and some of these are based on IDC studies about the OCP. So, but what we, for example, measured ourselves is that typically the maintenance tasks for the hardware are about four times faster with OCP gear compared to traditional rack mount type of gear. 65% more servers handled per person, operational person, 61% less productive employee time lost, and 38% less time needed to resolve unplanned downtime with the OpenRAC type of deployments and hardware. But in general, we definitely do see that it's a very good solution, good energy efficiency, providing good TCO for the deployments. Then I will move to this experiences part of the OpenRAC solution. So as said, we started the deployments of systems last year commercially, and it's something like 10 different customers where we actually have deployed as of today. But that is, as said, so heavily increasing during this year. But as said, so the experiences are now coming from the first deployments that we are seeing. So typical installations, what are there? So it's not like mega or hyperscale data centers that we typically see. So it's like 10 racks or up to 10 racks per one site for some purposes. In the centralized locations, it could be more, but as of today, we do see still that the deployments for this telco cloud they are fairly modest compared to the hyperscale systems. There are really no greenfield installations, so all the installations go to existing locations, and requirement is always to adapt to the existing environment and to the existing sites, which is creating some challenges for the, let's say, options for power feed, cooling, and so. Everything is expected to be still redundant, which means that the switches, cabling, all the storage is always many times redundant in many cases. So it's kind of a really different compared to typical IT enterprise type of deployments in that sense. Increasing the amount of hardware to provide the services, but of course then also increasing the high availability of the system. NEBS requirements still seem to be coming there. When we started some 3-4 years ago, we thought that, okay, we don't want to have NEBS anymore, or at least not everything from NEBS, but as we move forward, it seems to be so that the requirements are coming back again and again. Installations are always customer specific, so there is no one standard or common blueprint between the different operators or between the different regions even so there's a lot of variety in how the gear is actually being specified, what kind of configurations there are. It would be nice if there would be a common solution that could be utilized by at least many locations and of course also between the different telcos. And then installations that we have done, they vary from bare metal applications to NFV Telco Cloud IaaS platform with all the VNFs on top of that one. So then something I have, let's say, split the presentation so that there are experiences from different areas when we are doing the deployments. So one is transportation. So typically, if you think of the transportation, how we transport, so the rack and stack on site it's not allowed. So we are delivering pre-installed racks where everything is basically there. You just move it to the site and connect to the powers and to the uplinks to the network. Then the delivery type that we use, so typically the expectation for the lead time is very short. So air freight is something that we need to use for the pre-installed racks. So they are quite heavy equipment to put to an airplane, but that's how we do it. And And one challenge that we have seen is that the current, typically the rack is pretty high, and to get that to an aeroplane, so it's required to have a special plane and which don't fly every day from every location. That might cause some challenges there. So transportation tolerance, according to NEBS, is something that we see as a requirement, definitely. Some pictures, anything can happen in transportation. This is how we typically ship it. So we have everything installed in the rack, and then we put it into a big wooden crate, and then when it arrives, it can change the format completely. You never know what happens there, and nobody knows what happened, and nobody admits what happened. Then site physical limitations, we do see a lot. So the fully equipped rack, it weighs quite a lot. So it's about 800 kilograms, which means about 1,200 kilograms per square meter. And the floor load capacity quite often also limits the deployments. So it's something that, so we cannot have a fully equipped rack to be delivered. Then the rack depth is also an issue in some locations, and especially when we move towards the edge of the network. Some we see it's 800 would be the maximum. In the old edge sites, even 600 is the maximum. Of course, the open rack is much deeper and cannot go to auto locations. Then for the old sites, there are also other kinds of limitations like elevator capacity, delivery path height, and with the door openings, and which some cases means that even if we deliver the fully equipped rack, then at the sites, let's say the ceiling is very low, then we actually have to go out, and then we can move the rack to the location where it needs to be, and then put everything back again, which is a challenge. But this means that the site surveys are mandatory before shipping, and actually we see that this colo facility guidelines defined in OCP actually quite well match to that as well. That can be used. There are also some other telco requirements that we need to check, but in general for the equipment, actually a good starting point. Could be enhanced with the telecom requirements. Then power and cooling. So typically, actually, many of the sites, especially the existing sites, are something where we have the minus 48 volt DC power feed infrastructure with the battery rooms, and that means we need to adapt that. We have that available. But there's also a lot of different types of AC power feed options that are needed. Every country, and especially US, has several, and Japan and Korea. Rest of the world is more uniform in this sense. Then power cabling can be from top and bottom, which is the typical OCP open rack design is such that you have the PDUs on the top of the rack, which is a challenge when you need to then actually get the power from the floor and how to route the cables. There is something that's maybe not fully taken into account in the Open Rack version 2 design, but it can be done. Then the site power budgets are often limiting factor, as well as the cooling capacity, even down to 4 kilowatts per rack, which means that you cannot have too many servers in such installations, and it might be so that even the Open Rack is actually not the right solution for such locations. Then the battery backup units, we don't see that, and that has not really been seen as a requirement to us. Also, one challenge that we see is the transportation due to the lithium there. You cannot put those to the airplane. They have to be moved on the ground. Compliance is still seen as really important part. So there are a lot of kind of standard telco requirements for the environmental part, and for example, for safety, EMI, EMC, temperature tolerances, seismic tolerances, transportation. RoHS, this waste handling, fire resistance, energy efficiency, acoustic noise, and so forth. These are still coming and popping up. So as said, because when we started, we were thinking that, okay, not in data centers or not for this type of equipment, but we can really see that that's coming there again. Maybe the industry should be thinking that is it really mandatory. So then one concern that we see coming often is this Open Rack version 2 bus bar safety, and there, in my opinion, should be a standard solution for that one. We do have our own plastic covers for that, but it would be nice to see actually something that is part of the standard itself. Networking is something, so the installations, typically telcos, because of, I would say, the legacy, many of the applications are still something that come together with the legacy requirements for the networking, which means that they are very complex networking schemes and all the possible features defined for layer 2, layer 3 networking are often in use and need to be supported, which means that the open source, or let's say open networking Linux-based implementations typically don't fulfill the requirements, especially what comes to the redundancy features and the millisecond level recovery times for the failovers. What we see is that the NIC configurations, transceivers, due to the different kinds of cabling in the sites or existing cabling in the sites, is a challenge. There's always something different. Everybody wants to have something different. But then for the networking, it's typically so that it's 4 times 25 gig or 6 times 10 gigs per server. So it's quite a lot of connectivity and quite a lot of cables in the rack due to this, which is supported and can be done. Also, in many cases, we do offer our own switches, but in many cases, actually, the operators, they have selected their own switches that then need to be integrated to the racks, either on site or as pre-integrated. Then uplink cabling from bottom and from the top need to be supported. In typical, let's say, hyperscale installations, we see it's typically from the top, but both openings need to be there. Software support, so there is a requirement always for certification for commercial software products, especially for different types of operating systems like Red Hat Linux, Canonical, VMware, Oracle, and so forth. But we also do see that there's a lot of, let's say, interest that is moving towards the open source software installations or software platforms, especially OpenStack, OPNFV containers with the Kubernetes management. And so this is something that we are working with, and actually there was a demo in the Linux Foundation booth run by Nokia guys on the OPNFV installation or OPNFV platform running on OCP Open Rack version 2. Then onboarding of third-party applications. We are not just providing full Nokia solutions, but we are integrating VNFs and applications from any vendor on top of the hardware and the software platforms. Security is an interesting topic and really a broad topic, but just briefly that really it's taken very seriously by telcos and us as well. And there's a huge effort that we have spent and need to be spending in the future as well on testing and hardening the OCP gear. Main challenges we do see, it's not just the hardware, but really the firmware, BMCs, everything that is there on the switches and so on, that there's a lot of things to be fixed and hardened. Acceleration, maybe I don't want to talk about that here too much today, but there we do see that there's many functionalities, okay, in the traditional telco deployments that are actually being implemented with FPGAs, DSPs, network packet processors or ASICs and so on. And for some functionalities, we do see that this is also becoming a must in the NFV deployments with the OCP hardware, in order to be able to support applications like radio baseband processing, overall, let's say, EPC packet processing, performance, security, AI, machine learning type of things, and so So it's something that it's not just the x86 servers, but really other things coming as well. Data center management. In the open ecosystem, support for multi-vendor environment is a mandatory requirement. So that's something, as said, because we have the requirement to integrate switches and other gear from not only from us, but there really has to be a capability for multi-vendor integration for the management part. And what we see, RSD defines a good framework for the data center gear management architecture as such, and a good thing is that many of the things are now getting then also standardized in the DMTF Redfish side, that we see that's the right way to do it, and what we also follow and support. IPMI is still very much used also due to the integration to the legacy as well, or legacy management systems, but there really seems to be strong demand and movement towards Redfish. But one challenge has been that as of today, Redfish still is not complete in that sense that you cannot do everything using that. So they still need to fall back to some API functions or some OEM RESTful API functions then aside. But that's moving to the right direction. Switch management still is a challenge, so switch or different flavor in that sense that all the other gear you can typically manage through the let's say BMC or using Redfish, but then how to manage the switches, how to integrate those, and to have the BMCs integrated to the switch hardware actually would make it simple or similar to the servers. So in general, a lot of integration effort is needed to adapt to also to customer-specific configurations, and because of the fact that there are a lot of equipment from different suppliers typically required to be integrated. So in summary, what I have is, okay, call for action. First of all, I think there's a lot of things, what we discussed with the foundation people was that one thing, for example, is this OCP Open Rack and Power project group to participate in the central office applications for Open Rack work there. And then you can find more information about the products as such on our websites. But in general, we do see that there's a lot of different things. Part of this presentation we can talk in much more detail offline, but that could be taken to the OCP specifications and enhancing the existing solutions or creating new solutions. So in summary, we started the deployments of the OCP Open Rack compatible designs in the networks in 2017 for telco NFV infrastructure, as well as some bare metal application installations or deployments. Then we do see that many of the traditional telco requirements are still mandatory and need to be supported in the NFV telco cloud environment as well, and with the OCP hardware. But in general, experiences are showing that the OCP Open Rack design can work very well in telco use cases with the enhancements that are needed to fulfill the telecom requirements. So, thank you, and you can come and visit and see the gear that we are talking about in our booth in B6 there. Okay. Thank you.